Monitoring. The International Monitoring System, the IMS, is to consist the following 4 worldwide measuring networks: 15 primary and 120 secondary seismological monitoring stations whose technology is capable of distinguishing nuclear explosions from earthquakes or other shocks. Primary measuring stations constantly supply data, while secondary stations transmit data only on request. 11 stations for hydroacoustic monitoring, which monitor the oceans with special sensors for sound waves.
Over a network of 60 infrared stations, a high-sensitivity barometer for the human ear no longer measures air pressure fluctuations perceived as sound. Each station has to be equipped with at least 4 barometers distributed in an area with a diameter of approximately 2.5 kilometers. Each individual barometer records pressure differences of only 1/1000th of normal atmospheric pressure. Due to the spatial distribution of these extremely sensitive barometers, even the weakest signal can be still detected. Sound waves generated by supersonic airplanes when piercing the sound wall can be clearly distinguished from atomic bomb tests.
80 stations with radionuclide detectors detect radioactive particles, which are released only in atomic bomb explosions. 40 of these stations also monitor the concentration of radioactive noble gases. All data are collected, stored and evaluated in Vienna in the International Data Center, IDC. By May 2012, more than 280 of a total of 337 measuring stations, about 85%, had already been installed and functional. The Federal Institute for Geosciences and Natural Resources has been commissioned in Hanover to set up and maintain the seismological and infraacoustic facilities in Germany. The radiation monitoring station on Schauinsland is operated by the Swiss Agency for Radiation Protection. On the morning of 9th October 2006, North Korea carried out a nuclear arms test in the northeast of the country. The CTBTO International Monitoring System recorded the explosion with 22 seismic stations. Within 2 hours, the CTBTO member states received initial information on the time, place and strength of the explosion. 2 weeks later, a radionuclide measurement station in Yellowknife, Canada, recorded traces of a radioactive isotope of the xenon in the air. By means of atmospheric transport calculations, North Korea could be defined as the only possible source of the noble gas. The presence of radioactive xenon is evidence of an atomic explosion.
North Korea carried out a second nuclear weapon test on May 25, 2009. Significantly more seismic stations of the CTBTO 61 registered the event compared to 2006. On the one hand due to the stronger explosion, on the other by the progress in the construction of measuring stations. The area for a potential on-site inspection could therefore be more precisely defined in 2009. This area was 264 square kilometer compared to 880 square kilometer in 2006.
The measurement data of the ISM are also interesting for civil and scientific applications. Through the highly sensitive monitoring system and its own data transmission network, the CTBTO can provide valuable data for tsunami warning organizations, in particular seismic data. A corresponding decision on this data transfer was adopted in 2006. Due to relevant agreements, tsunami warning centers currently have direct access to relevant CTBTO measurement data in 8 mostly Indo-Pacific countries. During the nuclear disaster of Fukushima in spring 2011, more than 40 CTBTO radionuclide stations detected the global spread for radioactive isotopes from the destroyed nuclear power plant in Japan.